In this video, we're going to try to find the limit as n goes to infinity of this integral. Okay, the key idea here is that we have x is between 0 and 1, and we are integrating this function that depends on n. Okay, and the integral also depends on x. Okay, I think it's a good idea if you can stop here and work this problem by yourself. Okay, and I can give you one hint. Okay, in this case, we can find a primitive of this one, but this seems difficult. We can do this one using some induction, I think. I'm not sure, but we see that we are taking the limit of this part here. So we can treat this one as a sequence. We try to make it as a sequence, and we're going to use the squeeze theorem, okay, for sequences. So basically, we can try to make this one as a sequence. Let's call it an, and we're going to bound it by some sequence bn from above, and from below by some sequence cn. If we can prove that this one has a limit and this one has a limit, and they are the same, then this one must have the same limit. So this is an application of the squeeze theorem. But how can we do that? Okay, when I stop here and work this problem, it's good to try it yourself. Okay, let's solve it. So here we are given that x is between 0 and 1. Okay, we're going to use this fact to try and find a bound or bounds for this sequence here. Okay, here it means that t is between 0 and x, and x is in 0, 1. 1 is not included. Okay, so we can use some bracketing technique to find an upper bound and a lower bound for this one here. How can we do that? Okay, sure, let's go and do it. So we know that t is between 0 and x. Okay, we can include we can say it's less than bigger than 0 and less than x. Okay, here if we raise everything to the power n, we're still gonna have t to the power n is less than x to the power n. Okay, this is one key idea. Also, we have sine t is between 0 and sine 1. Why? Because here in the interval 0, 1, the sine is increasing. The sine function is increasing. Okay, and we have to find a bound for 1 plus t squared. We have t between 0 and x and 1, less than 1. So if we square, we're gonna have t squared is less than x squared is less than 1. Okay, adding 1 to both sides, we're gonna have, oh, let's be 1 plus 0 less than 1 plus t squared less than 1 plus x squared less than 2. Okay, and therefore we have 1 over 1 plus t squared is between 1/2 and 1. Okay, now we have some key IDs, some key factors. So we have 1 over 1 plus t squared is between 1/2 and 1. We have sine t is between 0 and 1 and sine 1, and we have t to the power n is between 0 and x to the power n. So these quantities, all of them positive. So if we multiply, we're gonna get 0 is less than sine t times t to the power n over 1 plus t squared is less than sine 1 times x to the power n over 2. Sorry, over the 2 is gone. Okay, so it's just this, the 2 is gonna go this way. Sorry, it's just 1. So here, so this is what we're gonna have. We don't need the 2. The 1/2 is gone in this way. So basically we're gonna have sine t to the power n over 1 plus t squared is less than sine 1 times x to the power n and bigger than 0. Okay, what do we do next? We integrate. This function is continuous for all the values t between 0 and x. Okay, in fact, this function is continuous for any t. But since we are working on this interval, 0, 1, we can integrate. We integrate the 0 function. We're going to get 0. We integrate this one between 0 and x. That's what we have. That's what we don't know. So here, 1 plus t squared less than. If we integrate this one, we're going to get sine 1 is a constant. X to the power n is a constant because we're integrating with respect to t. And all we have is the integral between 0 and x of dt. Okay? So this is just t. When we integrate, we get x. So therefore, we have the integral of sine t to the power n over 1 plus t squared dt is less than sine of 1 times x to the power n plus 1. Okay? And this is here where we can use the squeeze theorem. So this is my sequence. So this is my an. Remember when I said in. Cn is just 0. And bn is sine 1 x to the power n plus 1. Okay? Now I can take the limit. So if I take the limit, I get 0. The limit here of the integral between 0 and x of sine t to the power n over 1 plus t squared dt is going to be less or equal than sine 1 x to the power n plus 1. When I take the limit here, and since x is between 0 and 1, I get 0. So this one is between these two zeros. Therefore, the limit of this integral is just 0. Okay, according to the squeeze theorem. Okay, and that's what I needed to prove. So this integral is going to be 0. Okay, and it's logic because we are integrating something that's getting smaller and smaller because t is getting higher, bigger because of this n power. Okay, that's why this integral it's logically 0. Okay, and that's how we do use integration and the rules of integrations with the sequences to prove results like this. Okay, I think that's what we need. So we proved that this limit is 0. Thank you very much.